good evening or good morning, because as you Magda mentioned, actually we have attendees from all over the world to our webinar on familial hypercholesterolemia as an evidence-based model for innovation in cardiovascular diseases. The webinar is organized today on the FH Awareness Day by FH Europe, the European FH Patient Network. FH Europe is actively working to improve Europe-wide awareness, understanding, and access to prevention, diagnostic, and treatment of many inherited lipid conditions, specifically familial hypercholesterolemia, our topic for today, so that all those impacted receive optimal treatment and support, resulting in longer and healthier lives. You are all welcome to interact with our distinguished speakers, to ask questions, give comments, use the chat, and because we want to have a true interactive webinar today. My name is Marius. I'm a medical doctor. I'm a trustee and member of board of FH Europe and co-chair of the scientific and public health committee of FH Europe and founder of the Center for Innovation in Medicine based in Bucharest. And it is my pleasure to invite our speaker from today to quickly introduce themselves, and I will start with Professor Mafalda Bourbon from Lisbon, from Portugal. Mafalda?
Hi, my name is Mafalda Bourbon, and I'm a biomedical scientist at the National Institute of Health in Lisbon, Portugal. I'm also on the Public Health Committee of the FH Europe. And in Portugal, I'm the coordinator of the Portuguese FH study. I'm also on the board of the Ibero-American Network for FH and other projects, international projects on FH.
Thank you so much, Mafalda, and thank you for being with us today. And now we are moving to Professor Hans Lehrach from Berlin. Hans?
Hello, yeah, I'm Hans Lehrach. I studied chemistry in Vienna, got a PhD in more or less biophysics in Göttingen at Max Planck, then went to Harvard, did one of the first cloning experiments of cDNA cloning, so bacterial cloning, which was then just starting to be possible. Spent 9 years in CMBL in Heidelberg, where I started with first discussions on the genome project, and we developed the technologies to identify genes like FH on the genome based on their inheritance patterns. For example, in Korea, Huntington mouse genes. I was heavily involved in the Human Genome Project, moved to the Imperial Cancer Research Fund for 7 years, and then spent 20 years as director at the Max Planck Institute for Molecular Genetics, and set up different companies, including one which is particularly interested in developing truly personalized therapies for cancer using technologies which can also be used in, for example, cardiovascular diseases and many other areas of medicine.
Thank you so much, Hans. So we have with us a pioneer of the Human Genome Project, a big advocate for true personalized medicine, but it's also the case for Mafalda Bourbon from Lisbon, is also recognized at the EU level by the International Consortium for Personalized Medicine for her work in the field of implementation of precision medicine for FH patients in Portugal, and we will discuss about this later today. Also with us will be through a pre-recorded video, Professor Kausik Ray, the president of the European Atherosclerosis Society, and will share with us the insights from the most recent publication Professor Kausik Ray and his team did a few weeks ago in Lancet. But to start our conversation, I would like to ask you both, and I will start with Mafalda. Do we really need innovation in cardiovascular diseases?
Yes, we do, definitely. We have it already. I think in the last years, there's a huge part that it was innovated, with the new technology, all the sequencing technologies and all the information technologies as well. We are now able to identify FH patients early as they are born, actually. It's very cost effective to identify FH patients as early as possible, because then they can be counseled and they can be treated according to the disorder, and that will prevent cardiovascular diseases in the future. So I think this is one of the most important message of innovation, is that it allowed us to do that, to have the prices lower, and now we can identify FH patients in a very, very low cost. And of course, from the identification on, there's so many things that we can do. We can stratify the patient's cardiovascular risk according to several molecular biology techniques, and that will improve definitely the life quality and expectancy of these patients. And I'm sure we're going to talk about a bit more during the webinar.
Thank you, Mafalda. The same question for you, Hans. You already mentioned your work in the cancer area and potential for CVD, and I know that you have some projects in this field of genomics and digital twins and other omics. What's your perspective on innovation and CVD?
I think we desperately need new techniques in all of medicine. In all other areas, we have switched to using computer models to make mistakes which are unavoidable in any complex situation, quickly, cheaply, and safely on a computer model, on a digital twin of a car, of a plane. This is something we absolutely have to be able to do in medicine, because the therapies which are not ideally fitted to the individual have many negative consequences. They delay receiving the optimal therapy, but they can have also massive negative side effects. Up to 200,000 people die in Europe every year due to adverse drug effects alone. So I think we have to rethink medicine from the point of view of the single individual patient. Every patient is different, and every patient should be treated based on his or her individual biology. This was simply science fiction till a short time ago, but the fact that we have made enormous progress in molecular techniques, that we can now sequence 100 genomes in a day, while it took us 13 years and 3.6 billion to sequence the first one more or less 20 years ago. And many other molecular techniques now put us into a situation in which we can learn more about an individual patient than we knew about human biology a few decades ago. So we should move rapidly towards a truly personalized prevention and therapy choice in all areas, carrying out as many analyses as we can get the samples for. We are not limited anymore by the costs of the technology or their power. We are limited by which type of samples we can reasonably take of a a specific type of patient. Obviously, this is very different in a cancer patient or in a patient with a very serious disease or in an application in which we just want to keep an individual healthy. But I think it's a situation in which we originally started out with a medicine which basically assumed everybody was going to react the same way. Then we learned that this was not the case. And since then, we have been doing, in a sense, what epicyclists did to the Ptolemaic worldview by adding biomarkers and ad hoc solutions. We have to really rethink the whole problem. We have to switch to a Copernican worldview, a worldview in which every patient, every individual is unique and should be treated as unique. So we have the possibility to find appropriate therapies even for diseases which have never occurred before and will never occur again. And that's, for example, the case in cancers. Any tumor is different. Any tumor is different from any tumor which has ever occurred or will ever occur during the lifetime of the universe. So technology is driving this process. Technology is allowing us now to do things which were completely unthinkable before. And the limitations in many respects are probably not nearly as much technological. It is resources and the conservative attitudes in very large parts of the healthcare establishment.
Indeed, actually every citizen or every patient is unique and should be treated as a unique individual. And as you mentioned, the technologies and the data allow us to actually to rethink medicine and healthcare, as you mentioned, Hans, and to rethink the cardiovascular diseases and prevention for cardiovascular diseases. And you mentioned the personalized prevention, and I think we should, and we will explore this in our webinar, how personalized prevention could fit in the FH area. But first, in order to have a better understanding around the topic of FH, I'll invite you to the discussion I had a few days ago with Professor Kausik Ray, the president of the European Atherosclerosis Society, who will explain the publication in Lancet and actually the current state of the FH worldwide, and then we'll continue our conversation here. We are very happy to have with us today Professor Kausik Ray, is the president of the European Atherosclerosis Society. Thank you so much for being with us, Professor.
Marius, thank you. It's a great pleasure to support this wonderful initiative from FH Europe, and hello to everybody.
Before going into more details on your most recent publication in Lancet, based on your work for decades, I would like to ask you what, for you as a professional, means the innovation in this area of FH?
So I think the one most important thing I would say, I see innovation as a facilitator for large projects. So if you have, we've got a global population of 7 billion. We've got a condition, a genetic condition, that is the commonest genetic condition affecting mankind, with a prevalence of 1 in 300, 1 in 311. And we've found somewhere near 5 to 10% of all of those people who are affected. So that's a huge challenge. And without innovation, we can't find these people, we can't change their lives, because if we find these people and find them early, we have an opportunity to prevent, in many cases, disastrous consequences of this condition. And this is preventable.
As I mentioned, you recently published a groundbreaking paper on FH based on your experience for many years, and actually you involve a lot of people across the globe in this registry and in this paper. Can you tell us more about the work and about the conclusions of the paper?
Thank you. So I think one of the key things I wanted to do is I've been a member of the European Atherosclerosis Society for many years. And I've always been somebody who's been driven by not problems, but finding solutions. I mean, one of my favorite sayings is, there are no problems, only solutions that wait to be found. And going to one European Atherosclerosis Society meeting after another, we'd see this about FH. And I thought, well, we're all working individually in these clinics around the world. Why don't we come together? Because if we come together, we have the power of numbers. And I'm an epidemiologist, a cardiovascular epidemiologist, as well as a cardiologist by training. So I thought, well, if we could do this, then actually we can leverage data, because policymakers don't change things unless they see data for harm and inequalities, for example. So you need a baseline and you need those powers. And individually, a country might say, well, I've only got data on 50 or 100. But when you put the globe together, and there's nearly 200 countries, then we have the power of numbers and you have a movement. So we started this journey in about 2015 in Glasgow with the first steering committee meeting. And the vision was very simple. We will start, without exclusion, open to everybody, a global registry for familial hypercholesterolemia. Now, there was a lot of work that needs to go into the background. You've got to standardize how data is collected. There are people who'd never started. There were countries where there was no registry, there was no data collection, no systems, where we helped them get started. So the idea is, in time, every country will have enough information, enough expertise to be independent. But in the meantime, they can feed into this global data set. So gradually over time, we started collecting these data, cleaning these data, refined the data, so we were sure of the data quality. Then at a certain point in time, when we had enough data, we have about 66 countries, we have to adhere to various data sharing agreements, ownership policies, and those things have to go on in the background, because you are only as good as the quality. So for instance, in this way, we know that we have stops and checks and processes in place, and we can continue. This is not just a once in a lifetime we're going to do this. This is a living, breathing, organic data set which will grow with additional information. So what were the main findings? So firstly, I want to thank all of my colleagues around the world that have contributed, who are not just the national leads, who have all been cited, who can be found on PubMed as having contributed, all the national coordinators and investigators. The message is very simple. Familial hypercholesterolemia occurs in all regions of the world, irrespective of ethnicity, color. There is a gender equality. As you know, it's an autosomal dominant condition. But here's the first problem. We are diagnosing familial hypercholesterolemia, a condition present from birth, at the age in the mid-40s. Women are diagnosed later than men. Less than 2% of people are diagnosed before the age of 20. And that's the period of time when you can intervene most, because we know that if you find people, start treatment, you can actually normalize the life course. So this means at the age of 40 or in your mid-40s, we've missed 45 years of potential opportunity, 45 missed years of cholesterol exposure. Just think about that for a second. The next thing that we show is that the age of diagnosis, as it increases, the prevalence of cardiovascular disease also increases. Moreover, the prevalence of risk factors. So it's not just about cholesterol. but it's about people will develop diabetes, they'll develop hypertension, they may smoke. If you diagnose things later, what's your opportunity to change behavior and lifestyle? So yes, lifestyle is going to be important. You want to avoid things like weight gain, developing diabetes, smoking, putting lots of salt on your food. We've seen the data from the George Institute a week or so ago at the ESC. So early diagnosis is an opportunity to change behavior and institute treatment. We also saw gender differences as well. We saw that women were less likely to receive more aggressive cholesterol lowering treatment. Now you add that to the fact that they're diagnosed later in life. We saw that with cholesterol levels, the risk of cardiovascular disease goes up. But we also found that as many as 30 to 40% of patients often don't receive cholesterol lowering medications. We have treatments like statins and ezetimibe, which are generic around the world. And we know that the commonest abnormalities are LDL receptor mutations. But that means that there is one faulty gene and one abnormal gene. The one faulty gene and one normal gene. The normal gene, we can increase the expression of that with statins. And globally, when lipid lowering is used, it's principally statin-based monotherapy. It's about 80%. Use of combination therapy is really low. It's less than 20%. And use of newer treatments like PCSK9 inhibitors. When we started the registry, newer treatments like inclisiran, for example, were not available. Bempedoic acid was not available, but they will be, and they will feed into these gaps. So nature really doesn't care how you lower cholesterol. And for the FH patient, they will need combination therapies. They will need 2 or 3 drugs. So less than 3% of all of the people around the world achieve LDL cholesterol levels below 1.8. Now, what we show is that amongst those where combination therapy was used, in particular, where a PCSK9 lowering therapy was used, basically, you are much, much more likely to achieve sufficient reductions in LDL and achieve goals. Now, think about it, it's very logical. A statin or bempedoic acid, and to some extent ezetimibe, helps you make more LDL receptors. And that's a good gene that we've inherited from one parent. If we keep these alive longer by inhibiting either PCSK9 directly with a monoclonal every 2 weeks, or we're able to add a treatment like inclisiran, for example, where you are reducing the synthesis of PCSK9 with a twice-yearly dosing, you're going to keep those LDL receptors alive for longer, which means compared to the untreated state, you are reducing LDLs by 80%. So if you imagine we find these people earlier and we can start appropriate treatment early, we can pretty much normalize LDL exposure and prevent all of those later complications. Well, they're not later complications, they are premature disease, but all the things that will happen later on. We need to gain those 30 or 40 years of treatment. And it also actually means that, for our patients with FH, that testing in pediatrics and testing these, not just in the adult, we then move to the pediatrics, that has to come forward fairly quickly because we need to prove they're safe and acceptable. And then, try and put systems in place. So for me, Marius, one really obvious thing is we've got the tools. We just need to go and do it. We need to implement it. We have to basically work with patient organizations, take these data, share the data so they can reach out to the audience. But we need the policymakers to put money behind this and say, we're going to screen. We're going to start screening before the age of 10. The example is Slovenia, gold standard. And these are things that have to be done. They can be done. And if we do it, we can fix this.
Indeed, engaging with the policymakers is crucial, mainly when we discuss about this type of tremendous innovation, and I will come back to this. But first, You mentioned the technical meeting that will be organized by FH Europe on the October of 11, and you are all invited to register for this. The technical meeting, we raised the point of the need for a harmonized and unified approach when it comes to FH pediatric screening across Europe. Also important in terms of engagement with the politician is the launch in 3 days, actually, on the 27th of September, of the European Alliance for Cardiovascular Health, with FH Europe part of this. So there are developments in this area of policy in regards to cardiovascular diseases, and specifically to FH. I mentioned the tremendous innovation, and you show a lot of data, and I like the idea of the power of data. Actually, the power of data indicate that the point for diagnostic should be 20 years, 30 years before, at the pediatric age, maybe. And this will lead us to the era of genetics and the use of genetics and the genomics for early detection, maybe for screening, anyway, for being able to diagnose early FH. What are your views in this regard? It's an innovation. It's not so easy to be implemented in the health system, in clinical practice, in public health.
Well, I think that the beauty about this is that, FH is a genetic condition, which means that it's not like me looking at clinical signs and symptoms where there is a sensitivity, specificity issue of all of the things that we're doing. You either have it or you don't. There may be new mutations, there may be lab errors, but if you take all of those out and all things being equal, you can make a diagnosis. It's a yes, no. That tells you what to do with that patient straight away. And it also tells you about, unless their partner is affected because of the genetics, it's an autosomal dominant condition, that unless their partner is affected, we don't have to worry about the children. So there's basically those people in adulthood who've gone through where we have to have a different approach because we're making that diagnosis later, and we can scale this technology up fairly quickly and fairly easily. The costs have come down from even 20 years ago, whether it's a blood sample or actually it's a kit. It's like, we're doing PCRs for COVID, where it's posted and you do the swab and you send it back. That's a great example of why not being able to do that. So we know we have the infrastructure now to be able to deliver genetic and genomic screening, for example. We have to basically look at different models of care, how that will occur, but I think we need to agree what best looks like. What we don't want to do is set the bar low, because if you set a low bar, everybody picks the low bar, and then you get inequalities across countries, across regions, by age, gender, ethnicity, and so forth. So we need to get rid of that, because that's not a good thing. We need to agree on what's good looks like, what ideal looks like, and then people can set about in a benchmark of, I will do this aspect of this in the next year. I will do this. And you want to basically then use that data to say what you've achieved. And then you can model on how many events you've saved. And then we've got the real opportunity, who are the younger people with less subclinical disease, where now small changes being maintained for a long time will avert many of these disastrous consequences later. So it's different ways of doing things. And it's not always about the most expensive treatments and how they work, for example. Yes, we've got injectable therapies that can be given every 2 weeks that are potent, or twice a year. Those are fantastic. But in many regions of the world, they won't be available. But actually, 3 oral drugs can work just as well. If you use bempedoic acid, ezetimibe, and a statin. So we can get all of those things. And the key with all of this, part of it is access to medication, affordable medication. The key is starting early. Because if you start early, every bit is going to give you a much bigger return. It's like bank interest. You start late, you're going to have to put a lot more away. And that is a critical thing for our politicians to understand.
And I may add that it's actually the role of the politicians, national and the European politicians, actually to support us, to support the community, the patients and professionals involved in FH, actually to build the right models in order to be able to diagnose early in the lifetime the FH. Dear Professor, thank you so much for being with us. If you have, I don't know, a final message for the audience.
I do, and I think that what I would say is that if you look at the work that is going on around the world, this is a global disease. We are a global community. We are stronger together, and each of us, each of you has a role to play. Each of you can contribute to this journey. And the reason that I went into medicine was to make a difference. I could do so much with individual patients. I can do a lot more with research. And there are potential gains from our societies working together. The EAS together with FH Europe and other organizations come together because we see the value of partnership, of collaboration. But beyond those, there is also a role for funders and policymakers to play, because now we've been working on very much on a bottom-up approach where we can now make that additional thing is that top-down element, and they can make that happen. And that's what I think we should all be working towards all around the world.
Thank you so much, and indeed, you succeed with your aim to make a difference, at least with your work on the global registry, with the publication in Lancet, and the conclusion you share with us today. Thank you so much once again, Professor.
My pleasure. Thank you.
45 years of missed opportunities. I think it's one of the key messages of Professor Kausik Ray. And thank you once again for sharing with us. And I'll go to you, Professor Lehrach. You are actually in the middle of all these developments, from omics, digital twins, this type of concepts. But in reality, we experience 45 years of missed opportunities for a disease that is actually from the birth and could be identified early in the course of life. What's your perspective? Your mic.
Right, okay, thanks. I think this should be tested at birth, just like many other things are, and since treatment should be able to start immediately. In fact, I would hope that within a reasonably short time, most people will have their genome determined very early on, because this is not the only disease which can be seen in the genome and which can be treated much more or prevented much more successfully if you have it, if you know about it. Once you have your genome, the genome doesn't change. You can just every month have new publications which will give you additional insights, which might come up with additional treatments, which might come up with additional prevention steps. I think this is a very obvious first step. I would think that we should build on that, and we are trying to propose projects in which you, in addition to analysis on the things which change, for example, the metabolites and the lipid composition of the serum changes in CVD, for example, it changes depending on your lifestyle, on your environment, on many factors. And this is something which ideally we should follow in regular intervals, maybe quarter a year, maybe half a year. We should measure the epigenome of the circulating immune cells. We should have the transcriptome. We should have a characterization of the microbiome, the intestinal microbiome. And I think if we follow on top of interpretation of the genome, those parameters which we can measure either by molecular technique or by sensors, or in some cases even by imaging techniques, I think our medical treatment and prevention will become much more efficient. We spend in Europe alone 4.5 billion euros every day on the healthcare system. A lot of it on drugs which happen not to work on the patients who receive them, which might even harm them, on the fact that preventive measures are not taken in time. I think we're so used to diseases. People have been dying of heart attacks and of cancer for a long time, and therefore we don't see it as much as a problem as it should be seen. As soon as we have technologies which can avoid some of those deaths, it's inexcusable not to take advantage of them. And in fact, it's also not in the interests of us as taxpayers, because we are all faced with increasing healthcare costs which increase faster than the gross national product. And this in aging societies is obviously also an economic problem which will add to the load we leave future generations anyway, with problems like the global warming. So I think at least we should be able to avoid spending vast amounts unnecessarily on medicine, which could be much more effective. If we have a situation, for example, at the EU level, that funding for these new challenges, I think in the healthcare area was over the entire program was maybe 70 billion, which was the second smallest number for all global challenges. Considering how much money we are spending on the pandemic alone every day, this is just absolutely ridiculous. I think no company would survive if she was on this huge expenditure only prepared to spend such a minute amount on research and technology development and investments to change the situation where we have very good arguments that we can change the situation. So I think it is overdue that we rethink our healthcare system, that the politicians realize that we can change things, that we are not simply always going to be dying of the same diseases at the same age, that we will not always spend huge amounts on drugs, which happen not to work very often. I think we can achieve a lot. We are much more prepared to follow this logic in other technology areas. we realize that we have to invest in, for example, solar cells if we want to have cost-effective, cheap alternatives to coal-fired power plants. But it is beyond me why this same logic has not been accepted by the politicians deciding on the healthcare budgets and the research budgets, which could, in principle, lower the healthcare budgets by vastly improved efficiency.
Indeed, we really need different models to deal with the healthcare, from health system perspective to models for certain diseases. And we have to identify models, and this is one of the aims of our webinar and future activities, to see how exactly we can implement all this innovation you mentioned, Hans, actually for the benefit of all of us as people, as individuals, patients or not. And you mentioned, you already mentioned different omics, metabolomics and transcriptomics, and so on. This type of advanced analysis that in a way or another should be implemented in the clinical practice. And I will go now to Mafalda Bourbon. I mentioned at the beginning that you propose a project from phenotype to genotype and to treatment, highlighted by the International Consortium for Personalized Medicine. And I would like to ask you, and maybe to create a bridge with Hans, with the idea to use more omics and more this type of analysis to understand better the cardiovascular diseases, maybe FH. What are your findings starting from phenotype on FH?
Yes, we have proposed a model for personalized medicine based on that. Now we have great knowledge about the genetics and genomics of familial hypercholesterolemia, and we know that there's one phenotype, and in that phenotype, the FH phenotype, we can actually find more diseases than just FH. FH is definitely the most common, but we have other family dyslipidemias like cytostolemia or deficiency in acid lipase. So it is really important to apply genomics and genetics for the diagnosis, so we can identify the correct disorder, the correct metabolism that is affected in a patient. And then when we find and when we identify the mutation, the gene that is affected, then we can go into treatment. And the treatment is different if you have FH, if you have cytostolemia, or if you have deficiency of acid lipase. So it's really important, a contribution for that genomics gave us that allow us now to study FH diagnosis can now have the FH genes and also the FH phenocopy genes. Phenocopy genes are the genes for these disorders that I have mentioned. Another one is the recessive form of hypercholesterolemia as well, the ARH. And so we can study, we have, for example, in my lab, we have a panel of 8 genes to diagnose as FH. And then we can do more with that. We can actually study these genes, the 3 FH genes, we can do functional assays and determine the activity of the LDL receptor. And we have found in vitro that we can precisely determine the activity of the LDL receptor protein. That's the most important protein to clear cholesterol from circulation. And by that activity that is related to a variant, a specific variant, each variant will have a different LDL receptor activity, we can optimize treatment, for example. There's some mutations that only affect the LDL receptor function in 60 or 70%, or in 20% less effective. And those are the less severe variants. And maybe with just a statin and ezetimibe, you can decrease the high the high risk of these patients because they have high cholesterol. But if a patient has a variant that decreases almost to null their LDL receptor activity, so that patient needs to be much more aggressively treated. So now with 3 or 4 different drugs, because we have those in the market already. So FH has this wonderful scenario that is, you can identify the patient, so you can correctly identify the patients by genetics and genomics approaches, and then you can also identify which is the best treatment for those patients, studying the LDL receptor protein. And that's a bit of personalized medicine. If you can, find the exact limitation, the exact metabolism that is affected in these patients, and then if you can optimize the treatment according to the variant that it was found in the patient. So you're being as precise and as personalized as you can for FH patients. And there's even more on what Hans said, is that we know that the FH patients that have a clinical diagnosis of FH, we know that we only find a causative mutation in 50% of the patients. So there's another 50% of the patients that have a clinical diagnosis of FH, but we don't find a mutation in one of those 3 genes causing FH, the LDL receptor, apolipoprotein B, PCSK9. And in those, it's even more important to perform all the studies that Hans just talked. Metabolomics, I think, would identify the metabolism that is affected in these patients, and maybe find new genes for FH, or even new disorders of lipid metabolism. It doesn't, these patients, they don't have to have FH. They have a dyslipidemia, that's for sure, because they have high LDL values. Maybe they have FH due to another gene that we don't know, and we can find it by genomics and metabolomics and all these omics. Or maybe the patient has just another disorder of lipid metabolism. It's so important to identify exactly the correct metabolism, so that is affected. So then the treatment can be based on the genotype and not only on the phenotype, because we know that there's a FH phenotype that can actually hide other phenotypes. So we are in a very important era of technology that will allow us to be every day more precise and more personalized than before. And I think it's going to be extraordinary for FH, and will lead us to new discoveries, and for even more important for patients, they were going to be identified even earlier, even more correctly, and they are going to be treated even better than they are now. So I hope that in a few years, we'll have like 0 cardiovascular disorders in FH patients. I think that is possible, that we reach that time, because of everything we know, and identifying early these patients, it is possible to decrease the cardiovascular disorders in these patients. Of course, there's something that is very important and need to be said, is that the patients need to cooperate as well. So it's not like we find everything by genetics and genomics and find the right treatment, but then the patient, the lifestyle is not the correct, and the patient has other risk factors as smoking or hypertension due to environmental factors. So the patient really needs to cooperate as well. So that's really important, that the patients have that message in mind, that if we work together, scientists, clinicians, and patients, we are going to be able to, in the future, have 0 cardiovascular diseases in these patients.
Mission 0 cardiovascular disease
Exactly.
patients. I think it's a very good headline for our webinar. And I'll come back to you, Hans. We have many knows and unknowns issues related to FH, and maybe you can explore a little bit the polygenic scores, because it's a lot of excitement around these topics in relation with the CVD and other non-communicable diseases. And maybe in the model of the digital twin, maybe you can argue a little bit about the behavior of an individual and how important it is to assess this and to include, as Mafalda mentioned, also the behavior part of these large data sets.
Sure. Yeah, we are all different, not only because our genomes are different, we are also different because we behave differently. And I think it's our best chance to motivate everybody to also behave well by, for example, integrating sensor data with the molecular data, by being able to show the people how their behaviors, their eating habits affect their metabolome. I think one example I found quite striking is, in a sense, we treat airplane engines the way we should treat ourselves. Airplane engines have 25,000 sensors. Say every engine is individually modeled, so the computer model can determine which parts need uptake. We are more or less treated like Ford T's, which you supposedly could have in any color as long as it was black. So I think some more effort we put into our individual medical personalized treatment, so better for us, even if we are not considered as valuable as jet engines by the politicians.
Thank you, Hans. We have one question, and I think you, Mafalda, you're best positioned to answer this question. Can healthy diet improve the life expectancy even the cholesterol is high because of FH?
Diet, and it's important. It's important that the patient fulfills a good diet with low cholesterol. But of course, in an FH patient is not enough. I would say that when you're young, we have some patients, some children, and some young adults that they can not decrease as much as we wanted, but they can have lower levels of cholesterol because they are very slim. They do lots of exercise and they eat very well, very well diet, lots of fiber, lots of vegetables. And so when you're a child or even a young adult, we can see that it decreases the cholesterol level, but never to the values that a person in the general population should have. So an LDL below 115. So it is quite important because it does contribute to lower the cholesterol, but it's not enough. It's not enough. Usually for all FH patients is not enough.
I encourage you to send us questions. We have 7 more minutes from our webinar, and I would like to address one topic, discussing about screening and early detection. We are dealing actually with healthy people, with citizens. That's why I think it's very important to communicate with the large audience around all these highly innovative techniques around the data, around the personalized medicine, and to create the right links. And you, Hans, mentioned the engines and so on. Probably most of the people are familiar with this, but they don't. They're not linked the two areas. What are your messages in this regard of people interest in personalized medicine? Why they should be interested in personalized medicine, in personalized prevention for CVD? Mafalda and then Hans.
Actually, you know, the cardiovascular prevention and CVD, it's so important in FH patients, and all the strategies that we have been talking will allow us to reach that in FH and in CVD in general. You know, like for example, we have in FH, we have people with the same variant, and some have cardiovascular disease and some don't have cardiovascular disease. So this is another kind of group of patients that would be very, very interesting to do all the omics that Hans has talked about, because there's more than just the variant. There's other factors there that are determining. Of course, we know about some modulators, like having, you know, being a smoker. It's really important for the development of cardiovascular disease. So an FH patient should never smoke. But there's probably more than just the lifestyles and the FH mutation. And I think with all the studies that Hans said and described, we would be able to find other genetic determinants for cardiovascular disorders. And so in the future, I think we'll be knowing every day a bit more about all the strategies and all studies that we can do. But again, I would go back to something that Professor Kausik Ray and Hans said, that we need support from the governments to do research, more and more research, and to apply screenings, because if you don't identify an FH patient when the patient is a child, then you have those 44 years of life loss, like Professor Kausik Ray said, and those are very important years that you lose. If you don't find a patient, then you cannot. It doesn't matter if you know a lot about genetics and genomics, because the patient has not been found. So I think our major efforts need to be on awareness, education, and finding the patient, because the rest we already have. We have these wonderful techniques, we have wonderful scientists, we have even better clinicians that know how to treat these patients. What we really need is to find these patients as early as possible.
Hans?
Yeah, as a personalized medicine is the only way we can get really effective healthcare. In a sense, we are in a situation which corresponds to if we went with our cars to mechanics, say with luck, they can do something about 20 or 50% of the cars, but all the cars which have some problem which is not common, basically cannot get fixed. If we wouldn't put up with it for our cars, I don't understand why we should put up with it for ourselves.
Thank you, Hans. We have one more question, I think, for you, Mafalda. At what age does the panel consider to start treatment on heterozygote FH?
The recommendations are to start treatment in children above 8. So until 8 years of old, for heterozygote FH child, you should do lifestyle changes, diet, exercise, and after 8 years old, you can start treatment. There's lots of studies that they have proven that it's safe to start treatment after the age of 8.
Thank you. We have 2 more minutes. I will split one between 2 of you, and I will keep one for myself, because I have 2 announcements to make at the end of the webinar. My question to you, and the short answer, looking into the future of the cardiovascular diseases prevention, what is actually the best scenario you have in mind now? Mafalda?
I already said, the best scenario is 0 cardiovascular diseases in FH. So I think that would be, and I think that is the future, as I said, and that we can reach there. So that would be the best scenario for FH is 0 cardiovascular diseases.
Hans?
Yeah, I fully agree. The best scenario is 0 diseases for all common diseases and for all rare diseases. And at least it's a good aim to work towards.
Indeed, I think it's the aim we can all agree on, and I'm sure that also Professor Kausik Ray will agree that this could be our aim, our mission in this area of cardiovascular prevention through the use of innovation. And on the FH area, I would like to thank you so much, you, Professor Mafalda Bourbon and Professor Hans Lehrach, for being with us today and to share your insights in this area of innovation and the intersection between these old technologies and innovation and CVD prevention. As I mentioned, I have two, I think, very important announcements to do in the last minute of our webinar. Actually, are two invitations. The first one is for the launch of the European Alliance for Cardiovascular Health on Monday, 27th of September, starting 2:30 p.m. FH Europe is part of the European Alliance for Cardiovascular Health. I will discuss the launch of the Alliance on behalf of FH Europe about the need for innovation in cardiovascular diseases and cardiovascular disease prevention. This is the invitation, and the second invitation is for the already mentioned technical meeting on achieving equity and innovation in newborn screening and in familial hypercholesterolaemia pediatric screening across Europe. The event is organized under the umbrella of the Slovenian presidency of the Council of the EU on the October of 11. And I think my colleagues already shared in the chat the links with for the registration. Thank you once again to Mafalda and to Hans, and also thanks to Professor Kausik Ray for being with us today. Thank you FH Europe for organizing this event. Thank you Magda for all your effort, and Asha for the technical assistance. And I'm wishing you a very good weekend, and hope to see you on Monday and then on October 11th.
Thank you.
Thank you, everyone. I think we can close this webinar and everyone can go and have a well-deserved weekend and a glass of healthy drink to celebrate FH Awareness Day. Thank you so much to everyone joining us from all over the world. Hopefully you found it interesting. You will be able to see the recording of this webinar, and we will share the links to the events in our post-event email, which you will be receiving tomorrow. Stay safe and see you soon. We're closing now, so wishing you everyone a lovely evening. Bye-bye.
Goodbye.